So today we're going to talk about a few of the issues as they're connected to a drag box and solving the problems or having good solutions for driving a box down to the ground, dragging the box through the trench, and you're doing that to lay pipe. So the best way you can protect the pipe that you're laying in the ground. And then we're going to go over some of the versatility of the box, bringing it into a system to using it different ways and having more possibilities. So as you invest in, when you invest in trench safety equipment, you need to make less of an investment but get more versatility out of it. And then last, we're going to go over the rigging of a box, what is good rigging points, what they are and how they work. Cundall Industries, in its initial basic design of the Titan Shield panel, come up with a system of manufacturing of bending and folding steel, similar to the way they make the new automobiles today. When you go out in a construction job site and like to look at the excavators, they're not using tubes or pipe to build the excavators. They're using solid welded composite structures to get better weight to strength ratios. So Cundall Industries, or the Titan series, is a series of bent and folded steel plates, and then that we weld the components together to create a complete composite structure. But because of that, we've been able to put heavier steel where it's needed and lighter steel where it's not. So one of the most important areas as far as needing thicker, more durability steel is the perimeter. And I like to call that the ring of steel. So we can start right here with the end of the unit. It's a solid vertical member from top to bottom. On this box, it happens to be 1/2 inch thick steel plate that's bent into a C. So you have at the very top down to all the way down to the cutting bar at the bottom. It's all thick steel. The bar at the bottom is 3 inch by 1/2 inch bar, cutting bar, coming across all the way across the bottom, back up the other side, and then coming across the top is a 1/2 inch bar, solid across the top, and then a 4-foot tamping block on top of that. So, coming up to then next to the driving area, we have a vertical member with the 1/2 inch thick steel into. Then we come in 4 feet, 3 to 4 feet, depending on the box, and we have what we call an internal pounding member of thick steel. Then we have a reinforced beam between the two driving areas. And then we have on top of that now that 1 inch thick steel tamping block. So any in this zone in this area, you can drive the box down. We've already kind of talked about that in previous videos about driving a box down the ground and why it's needed. And one example is the drag and drive method. Once you lift the box, when you're in unstable stall, you lift the front of the box up, and then you drag it ahead, and you have it at an angle, then you need to drive it down. So that gives you good, stout driving points that you can hammer the box down into the ground. Okay, so also for driving the box down the ground, it takes good racking to allow that to drive down the ground. So actually when you're driving the ground, you're driving one side down, you're driving the other side down, then you excavate inside, dump the soil out. Drive another side, drive the side down again, drive the other side down, take the soil out. So a box needs able to be racked to drive it down the ground. And that's another reason we come up with these short, stout solid steel sockets on the boxes. So it allows the box to be racked as you drive it down into the ground. And also note with the sockets, we have 3 sockets in the face of a box. Okay, that's the front of the box. And then also we have 2 sockets in the back of the box. So as you drag the box ahead, the pipe is always being left behind going through the back socket. But in turn, if you wanted to set this pipe to do repair work over an existing line, you can leave out the bottom spreader, and now you have what I would call a utility box. You have the spreaders the same location, front and back. Okay, now I'd like to go on to the next issues of just dragging a box. Again, where you just dig a trench down into the ground, just lift the whole box as a unit up, set it all the way down to the bottom. And at that point, you would just dig in front of the box, down to the bottom of the ditch, and drag it ahead again. You want the box to fit in the trench as snugly as possible. But one of the issues when you drag it ahead, if there's a certain amount of protrusion of the wall of the bank, soil, coming in where you're dragging the box into, what you want in a trench box is a cutting edge at the front of the box. So what we do in our Titan design, we bring the outside skin past the end tube, then we put a nice thick heavy weld into that area. So now as you're sliding or driving the box ahead, that you're slicing the soil, so the box does fit snug in the trench, what you want, but also you don't want to drag the box in to get the box stuck in the ditch. In other words, you wouldn't want a rounded corner here that would let the box get froze as you're trying to drag it. You'd want to actually cut the soil as the box moves. So that's one issue that we solved for dragging, just dragging. The next issue we talked about earlier was the deflection of the sidewall. Okay, so we happen to be looking at here is a 5-inch wall. And remember I explained before, the wider the wall, the less deflection there's going to be for the length of the box. The narrower the wall, a longer box, there'll be more deflection. So in our standard boxes, we went to, instead of going to a 4-inch wall, like most other box manufacturers, we decided to bump it out to a 5-inch wall, making it a little bit of a thicker wall. We're able to make the box a little bit lighter because of that, but also we also gain a more rigid box that doesn't deflect as easy. But and also what we did in connection with that is for down into the pipe zone is that we actually did a higher taper. We did a 1.5 foot taper. So actually in a pipe zone, we're actually narrower with the 5-inch wall than the manufacturers of 4-inch wall trench box, because they just put a short taper, an 8-inch high taper on their box. But that's another issue as we get into it, is in a trench box, is you really want a trench box for also, as you're protecting the employee, you also need to protect the product that you're putting in the ditch or the pipe. So when you put a pipe in the ground, obviously you need to put bedding up and around and over top the PVC pipe today. So the high taper also gives you that ability, when you drag the box ahead, you're leaving a less of a void behind, where it's less apt for that pipe to maneuver around, and then you get a deflected PVC pipe. Another area that we've done, we've always kept the bottom of the box really clean. So as you're sliding it and sliding your bedding out the back of the box, there's nothing protruding out the side of the box, like rigging points on some of the competitors at the bottom they put. So what's apt to happen when you're dragging a box and you're getting the pipe you're laying close to the sidewall and you're dragging it ahead, that protrusion then has a possibility of pulling your bedding material, which in turn then could pull on your pipe and could pull your pipe apart. Now you got a dislodged joint that you have in the ground that you have to fix after you put the pipe in.